Hello students and welcome to Chemistry B. I'm Ms. Slate and today we're going to be talking about limiting reactants, how we determine what reactant is limiting and which one is excess, and how we can determine the remaining amount of excess reaction for a reaction. So first off, a limiting reactant is the reactant that is completely used up in the chemical reaction. And when the limiting reaction is used up, the reaction will stop. So once the limiting reactant has been completely consumed in the reaction ends. All other reactants are said to be in excess. So there's always one limiting reactant and any other reactants are excess reactants. So let's look at an example problem that deals with this. So our problem, they give us a balanced chemical equation for the combustion of methane, and they say, what is the limiting reactant when 10 grams of methane is reacted with 30 grams of oxygen? The limiting reactant is always going to be the one that produces the fewest moles of a product. So basically what I'm going to do is I'm going to pick one of my products. I'm going to pick carbon dioxide for simplicity. And I'm going to see how many moles of CO2 will I get from my 10 grams of methane, and how many moles of CO2 will I get from oxygen. Whichever one produces the lower amount, that will be my limiting reactant. All right, now when we compare these, so we converted our 10 grams of methane to moles of carbon dioxide and our 30 grams of oxygen to moles of carbon dioxide. We can see that a lower amount of carbon dioxide is produced from the oxygen. So that tells us oxygen is the limiting reactant. The second question says, how many grams of water are produced from this reaction? Well, since we know O2 is the limiting reactant, that means the amount of O2 is what is controlling the amount of each product. So what I'm going to do is I'm going to take my 30 grams of oxygen and convert it to grams of water. Again, if you want to know how much of a product is produced in a reaction, we have to start from our amount of the limiting reactant. That's why this initial step here is very important. And we get for our final answer roughly 16.9 grams of water. Our third question is, which reactant is in excess and how much remains after the reaction? Well, the reactant in excess is methane. Being the reactant in excess means there's going to be some methane left over at the end of the reaction. Only the limiting reactant gets completely used up in the reaction. So to figure out how much methane is left over after the reaction, we first need to figure out how much of it is reacted. Once we know how much of it is reacted or used up in the original reaction, we can subtract that from the original amount. So basically what we're going to need to do is we're going to take the initial mass of methane and subtract the mass used up in the reaction, and that will give us the mass of methane left over. So it's going to take us a couple of steps to do this. The first thing I'm going to do is just calculate how much was used up in the reaction. To figure that out, I need to again start with the limiting reactant, O2. Anytime we want to know how much was used in a reaction or produced in a reaction, we have to start with our amount of limiting reactant. So I'm going to start with my 30 grams of O2 and convert that to mass of methane. So we find that 7.52 grams of methane is used up in the reaction. So this represents the amount used up. The initial mass is our 10 grams. So the next thing I'm going to do is I'm just going to take my initial 10.0 grams of methane, subtracting the 7.52 grams that was used up in the reaction, and that'll tell me how much is left over. And rounding to significant figures, we get 2.5 grams of methane is left over. So limiting reactant problems do require a few steps, and that does require some work, but it's really nothing that we haven't already done stoichiometry-wise. But let's look at one more example. Here we have the balanced chemical equation for the creation of water, and it tells us we have 10 grams of hydrogen reacting with 100 grams of O2, and we need to figure out which one is the limiting reactant. So we need to figure out which one of these is going to produce a smaller number of moles of water. So once again, I converted my mass of hydrogen and my mass of oxygen to moles of water. We can see that hydrogen produces the smaller number of moles of water, and so that tells me hydrogen is my limiting reactant. So the next question is, how many grams of water are produced from this reaction? Well, in this case, we can make our work a little bit shorter, considering we know we need to start with our mass of hydrogen, and we already know how many moles of water are produced from 10 grams of hydrogen. So we can just take this moles of water from the first part and bring it down here and convert it to grams. And we get 89.4 grams of water produced in the reaction. The second question, which reactant is in excess and how much remains after the reaction? Well, first and foremost, if hydrogen is the limiting reactant, that means oxygen is in excess, the excess reactant. And just like last time, to figure out how much is left over, I need to take the initial mass of oxygen, subtract the mass that was used up in the reaction, and that will give me the mass of oxygen that's left over. To figure out the mass of oxygen that was used up in the reaction, I need to take my 10 grams of hydrogen and convert that to mass of oxygen. And we can see this reaction uses up 79.4 grams of oxygen. So then we just got to do our subtraction to figure out the amount that's left over. So that would be the initial 100 grams minus the 79.4 grams, which gives us a leftover amount of 20.6 grams of oxygen left over. And that's how you do limiting reactant problems.